Welcome to MFM2PI, 5th unit trigonometry. This is our 8th lesson, real world problems using trigonometry. So our objective today, of course, is to do some real world problems using trigonometry. We're going to look at two distinct types. The first will be angles of elevation and the second will be angles of depression. So we're going to make a real world problem, integrate it with trigonometry, and then solve for a particular piece of missing information. Let's get started. An angle of elevation problem, as it says right here, refers to the angle between the horizontal line, which would be like the ground, and the line of sight up to an object. So that's all we have to really remember. So you don't have to write this part down, but it would be like if you were down here and you were looking over at something up in this direction. So you're down here, there's your eye, looking up at whatever is up there. That's what you would be looking at. So this angle here, as you look up, would be our angle of elevation. So let's look at this real world problem and see if we can't apply that. From a point 15 meters from the base of a building, Mr. Smith measures the angle of elevation up to the top of the building to be 46 degrees. How high is the building? So a question like this, I'd always like you to start with a diagram. That way you can get into the diagram the piece of information that you know, and also get a better sense of how to use your trigonometry to get the piece of information that you're missing. So let's start with the building, and I'm just going to do a little drawing of this off to the side. So here's the building, and there it is. And I'll also draw the ground underneath the building, kind of. There it is. So there's the ground underneath the building. So it says that, there's our building, I'll scooch it down so it touches the ground, from a point 15 meters from the base of the building. So I will do myself here in blue. So here I am 15 meters from the bottom of the building. So there's me, and I am looking up at the top of the building. So there I am, looking up, top of the building. There we go. So I'm going to put a couple labels on here, just so that we can remember what everything is. So this is building, and next I will label myself. This is Mr. Smith down over here. Mr. Smith hanging out 15 meters from the bottom of the building. So now we've got ourselves labeled here. Now we're going to put in pieces of information that were provided for us in the question. So for example, from a point 15 meters from the base of the building. So there's the base of the building, which is the bottom, and there's me. So that's going to be 15 meters from the base of the building. That's this distance right here. So there's our 15 meters right there. And the next piece of information we're given is that the angle of elevation to the top of the building is 46 degrees. So I will put that in as well. So that's this angle here of elevation. That's going to be 46 degrees. Let's move that 15 a little bit out of the way here. There we go. So we have two pieces of information. The next thing we want to get down is what we're looking for. How high is the building? That usually shows up, if you're looking for a pattern, that's the information or the piece of information that they ask you to find, usually shows up at the end of the question. So how high is the building? So for us, that's going to be this right here. How high is the building? So that's our setup. That's a good looking diagram. Now we need to figure out how we can solve this. So let's start by putting in a reference angle. Now this reference angle here has been given to us as 46, so I'll color that in like usual. Now you know what, before we do this, let's also talk about the fact that we can assume that this is going to be a 90-degree angle here between the ground and the building. Now is that strictly speaking true? Probably not, but for a question like this, that's a safe assumption to make. So that's an assumption, but that's okay. That 90-degree angle there we're going to make. So moving on, we've got our reference angle at 46 degrees. From our reference angle, this side here is the hypotenuse, this side here is the opposite, and this side down here is the adjacent. So for our purposes, let's do a Sohcahtoa, and we'll see which trig ratio we're going to use. So there's our Sohcahtoa, and now let's ask ourselves, what pieces of information are we given? Well, we are given adjacent, so that's the A. So sorry, sine, that's not going to be U. And what piece of information do we want? We want the opposite, so that's also not going to be cosine. Tangent is going to be the one that we're using today. So let's write this out. The tangent of theta, because we didn't really put any letters on this thing, so we'll say the tangent of theta equals the opposite over the adjacent. That's our bare bones trig ratio. Now let's fill in some information that we know. So the tangent of 46 degrees is equal to the opposite side, which we don't know, and we called it x, over our adjacent side, which is going to be 15. So there's our setup. The setup is really the sort of the new part of this. It's not, it's no different than solving any other value in a right angle triangle. It's just this time we had to get it out of a real world problem. So we're going to set this over 1, and we are going to cross multiply to solve this. So there's our cross multiply setup. We are going to have x, whoops, let's stick with the same color. So we're going to get x is equal to the tangent of 46 degrees times 15. That's going to be what I type into my calculator. So the tan of 46 degrees times our 15, and that's going to give us 15.5. So x equals 15.5, and that was meters, I believe. Last thing you need in a word problem is a little therefore statement to sum it up. Doesn't have to be long, doesn't have to be wordy, does have to be there. So therefore the height of the building is 15.5 meters. And I like to put it in a little box just so that I can identify it. So there it is. There is our first real world problem. Let's move on to angles of depression. Now, angles of depression are similar to angles of elevation, except they're kind of the opposite of that. In that, angles of depression refer to the angle between the horizontal line and looking down at some object. So in this scenario, what you'd be imagining is you'd be the thing up high. So say this is you up here on top of a mountain or something like that, and you're looking down, say like at a tree or something over here. So here is your like sight line off into the horizon. The angle of depression is the angle that your eye goes through as you look down at some type of object. So with that in mind, let's read this problem and let's set it up. A plane is coming down to land at Pearson International Airport in Toronto. The angle of depression is 22 degrees. The plane is 350 meters from the landing point along the ground. How high is the plane? Okay, let's do a little drawing here. So let's start by making an airplane. I will try my best to make an airplane. This is a terrible airplane. Kind of looks like a spaceship. We're going to go with it. So there is our spaceship. Now what we know is that the sight line from this particular aircraft would be going off in this direction. But Pearson International Airport, which I will draw down here, looking something like a colored in rectangle, is over here. And again, I'll draw the ground in under Pearson International Airport. Let's put our airport on the ground. So there is our airport, there is our airplane. What we know is that the angle of depression, so that's the angle that our plane would go through as it would head down towards Pearson International Airport. Let's get you on the airport. So there it is right there. So this is our angle of depression right here. You could imagine that as the plane sort of tilts its nose down, that's the angle of depression. And that's what we want to remember. So we can now start to fill in some pieces of information. What we know, and I'm just going to put some straighter lines here, so I'm going to just erase this, and we're going to make an actual straight line coming out of that plane. So there's our straight line. We'll stick it out over this way. So what we know is that the angle of depression is going to be 22 degrees. So I'm going to put that in right now. There's my 22 degrees. What other piece of information do we know? We know that the plane is 350 meters from the landing point along the ground. So that's important. So what they're actually saying is that this distance right here to the airport is 350 meters. So that's what we're looking for right there. So fortunately for us, this triangle that we're constructing is kind of up over here. It's kind of hanging out up in the air, but that's okay because this would also happen to be 350 meters. If you can sort of see that, because both the top, that'd be like this piece up here, this piece, and this piece would be equal. So we can just write the 350 up there. Again, we can assume there's going to be a right angle in here. In real life, probably not exactly 90, but that's an assumption, a reasonable assumption for us to make. So what we're after, it's that last thing that shows up, is how high is the plane above the ground. So literally, they're looking for this height here, which fortunately corresponds to this here. How high above the airport are they actually? So let's figure this thing out. Let's start by drawing in a reference angle. So our 22 degrees is already right there. Let's color it in. So from there, we've got our hypotenuse, we've got our opposite, and we've got our adjacent. Let's do a Sohcahtoa and see what we need to use here. Sohcahtoa. And let's see, first, what do we know? Well, we know that the A value is one that we already have, so we're not going to use sine. And we want the opposite value. So once again, we're going to be using tangent. So let's write a bare bones tangent out there for ourselves. So the tangent of angle theta is equal to the opposite over the adjacent. The tan of 22 degrees is equal to our opposite, which we don't know, over our adjacent, which is 350. And like a regular trig ratio, let's go solve this. Put it over 1. We're going to cross multiply here. We've got it here set up. So we've got x equal to tan of 22 degrees times 350. And that I will type into my calculator. So the tangent 22 degrees times 350 equals 141.4. 141.4, and that was meters. So that's how high our plane is above the ground. Last thing we want to get in here is a little therefore statement. So therefore, the plane is 141.4 meters high. And we will put a little box around that, and we'll call it a day. So those are angles of elevation and angles of depression. Please feel free to listen to this lesson again if you are not sure of any of the things that we've done. If you're feeling good about this, head to the self-assessment. Following the self-assessment, a mastery test, and then you're on to cheat sheet and practice test, friends. So good luck.